Section 3.2 discusses the process for naming binary covalent compounds, meaning we're making compounds out of only two nonmetals. By the time you finish this lesson, you'll be prepared to name covalent compounds given the formula, or write a formula given the name. Let's begin. Two nonmetal elements can often combine in a variety of ratios. For example, carbon and oxygen can combine in a 1-to-1 ratio or a 2-to-1 ratio. How do we name them so we know which carbon-oxygen compound we're talking about? Binary covalent compounds use prefixes to indicate the number of atoms present. CO becomes carbon monoxide, while CO2 becomes carbon dioxide. We'll use the prefixes 1 through 10 in general chemistry most often, so be sure to memorize them. Note that the last O or A of the prefix is dropped when the element name begins with O, such as oxygen. This avoids trying to awkwardly pronounce a word like tetraoxide, which becomes tetroxide. Let's look at an example. Here's the first piece of our nomenclature decision tree we'll be building in Chapter 3. The first nonmetal in the formula gets a prefix for any subscript greater than 1. The second element gets a prefix, but we also drop the original ending and predicate it with ide, IDE. Following this example, we see N2O becomes dinitrogen monoxide. Let's work through some examples. What do you call the compound formed from 1 atom of silicon and 4 atoms of chlorine? If it helps, write out the formula. What do you call the compound formed from 1 atom of sulfur and 3 atoms of oxygen? What do you call the compound formed from 2 atoms of phosphorus and 3 atoms of sulfur? What do you call the compound formed from 1 atom of sulfur and 2 atoms of bromine? Here's more practice. Pause the video and try naming each of these binary covalent compounds. Let's switch gears. Can you write the formula given the name of the binary covalent compound? Pause the video to try it. The binary compounds of hydrogen are often acids, which follow a different naming system. Some binary hydrogen compounds are hydrides, meaning the hydrogen comes last in the compound and are given special names, such as the common name ammonia for NH3 and the names phosphine and arsine for the hydrides of phosphorus and arsenic, respectively. As always, I'll leave you with the parting thoughts of the authors.